Welcome once again. I'm Meghamala, working as Assistant Professor from Electronics and Communication Department in Institute of Aeronautical Engineering. So, coming to today's topic is about blocking statements, procedural continuous assignment. So here, we will see what are these blocking statements and what are the procedural assignment statements. So coming to the statements or else coming to the assignment, in the previous classes, we had already discussed what is an assignment. So what is an assignment? Assignment is nothing but dumping the values onto a variable is nothing but the assignment. So here, for example, these are my variables. A, B, C are my variables, for example. Now, I wanted to give some values onto some variables. So here I'm giving 20, 10, 20 and 30. So this is nothing but an assignment. So when it comes to the assignment, we have different types of assignments. Continuous assignment, procedural assignment and so on. So, and also what is the blocking statements? What are the statement basically? So statement is something that you are conveying, isn't it? So in the statement, something if you want to convey something, in the sentence form we will convey, isn't it? So here also in the Verilog, when you are writing a code, okay, when you are writing a code, you will write like this, right? Module and gate, for example, module and gate, and this is a port list. Okay, and now what I'll do, I'll initialize the inputs and outputs. Okay, and then I initial and then I'll begin. So these are nothing but the statement, isn't it? So these are nothing but the statement. What does the word blocking statements mean? So here there are two ways, or else there are ways to group a set of statements together that are syntactically equivalent to a single statement. So syntactically, if they are equalized to a single statement, syntactically, if they are equalized to a single statement, then these statements are nothing but the block statements. Okay, so here the group a set of statements together that are syntactically equivalent to single statement is nothing but a block statement. So there are two kinds of block statement we'll see here. One is sequential and the second one is parallel. So in detail we will discuss what is sequential and what is parallel statements. So coming to the sequential statements, as the name indicates, sequential statements are nothing but the execution of a particular statements will be made sequentially. Okay, so one after the other, the execution of the statements will be done over here in the sequential statements. But in fact, what does the word sequential statements mean? We will see. These sequential statements are wrapped using begin and end. So here, this sequential statements, these are wrapped, or else these statements will be made in between or else inside the begin and the end keyword. So we can say these are the sequential statements. Okay, then will be executed sequentially in the given order. So as the name indicates, sequential statements, these sequential statements, these are wrapped using begin and end keyword. In between the begin and end keyword, these statements will be wrapped and they will be executed sequentially one after the other. Okay, in the given order, the execution of these statements will take place. And delay values are treated relative to the time of execution of the previous statement. So with respect to the previous statement, for example, I have statement 1, statement 2 and statement 3 and so on. So here what happens? The execution of statement 2 happens with respect to the statement 1. So here if the statement 1 is executed with a delay of 10 nanoseconds, then obviously based on that delay time, the statement 2 will goes for the execution. That's how the statement says that delay values are treated relative to the time of execution, okay, of the previous statement. So if particular statement 2, if it wants to, if you want to execute the statements 2, the delay will depends upon the previous statement. That means the delay will depends upon based on the previous statement 1. Okay, so this is what we will see in the sequential statement. Basically, sequential statements are nothing but these are the statements where they are wrapped under begin and the end keyword. So whatever the statements are the mention or initialization of the statements within the keywords begin and end, then those statements are calling it as a sequential statement. And also remember that these sequential statements, they execute in a given order, okay, one after the other, sequentially, in a sequential manner, these statements will be executed. And when it comes to the delays, the statement of the present statement, the execution of the present statements depends. The delay for the execution of the present statement, it depends upon the previous statements, okay. That means, for example, if my statements 2 goes for an execution, then it has to see whether the delay based on the statement 1. So, for example, statement 1 got executed with a delay of 10 nanoseconds. Then after 10 nanoseconds, my statement 2 will goes for the execution. So, this is what we will see in the sequential statements. But remember that the sequential statements always lies in between begin and the end keywords. So, when it comes to the keywords, already in the module 1, we have discussed different types of keywords. Module, end module, if, begin, end, and end module. So, these are the different keywords. These keywords are used, they are mandatorily used in order to write a particular program or a syntax. So, here, when it comes to this slide, this is an example, okay. So, here is an example. After all the statements within the block are executed, control may be passed elsewhere. So, after all the statements within the block, so here within the block, if the statements are executed, then the control may be passed elsewhere. So, in order to, as it is a sequential statement, the statements should execute sequentially in a given order, isn't it? We shouldn't see any overlapping or else any kind of chaos is not be seen over here in the sequential manner. So, in order to see the execution of each and every statements, particularly in a given order, then the control signals will come into existence. That like how is the statements, after all the statements within the block are executed, okay, if here for example I have 2 statements, but sometimes in some cases we may see more than 5 statements or else more than 10 statements. Okay, based on the module that you are considering. So, in such cases, we may see that the overlapping or else the execution of the statements being done based on the priority. Okay, sometimes the unpriority statements may execute first, and then the priority statements may execute first or the last. So, we will see some chaos. So, in order to clear all those things, the control signals may be passed elsewhere. Okay, in between the execution, the control signals may be passed elsewhere. So, here in this particular example, we'll see initial begin, okay, with the data of 8HFE is nothing but the hexadecimal, 8 bits of hexadecimal. And here also 8 bits of hexadecimal data I'm considering. But when you observe here, the timing control or else a delay is the delay we see when it comes to input 1 and input 2, we see there is a totally 30 nanoseconds of delay is observed. Okay, so first what happens is with 10 nanoseconds of delay, this statement 1 will execute, and then follows with the 20 nanoseconds of delay. This second statement will goes for the execution, and then finally I'm ending up with end module. End is a keyword. Okay, so this is a small example. Here we'll see another example with the module design. Here I'm considering a bit of 32 bits of data. Initial block starts at time 0. Okay, so here the initial block it starts at time t is equals to 0. Okay, so initial begin. So here after 10 nanoseconds of data, it's here the data starts execution at 10, right? So after 10 time units, that means what, at 10 nanoseconds of time delay, the data comes off flowing as OXFE. That means what, 10 nanoseconds of data, that with a delay, the data HFE will goes for execution. That's how, if you want to see the delay in the output, then the display time and data with respect to the percentile. Okay, so next afterwards, the data of 8 bits of hexadecimal will goes for the execution after 20 nanoseconds of delay, isn't it? So after 20 time delay, the data OX11 will comes into existence. So here 20 data 8 HFF, and if you want to display along with the initial propagation of the waves of, or as a propagation of time delay of input A and B, if you want to see, then display time data. Okay, and then N with the keyword end module. So this is how a program will be made, or else the syntax will be written when it comes to the sequential statements. So here, one after the other. So after this statement execution, the second statement will goes for the execution. But the important and the things to remember when it comes to the delay is, always remember that the statement 2, it just goes for a propagation unless and until based on the delay of the first statement. Okay, if it is going with a delay of 10 nanoseconds, obviously the statement 2 has to wait for 10 nanoseconds and then it starts its execution. So totally 20, after 30 nanoseconds, the output may be observed. Okay, so one after the other, sequentially in a given order, all the statements in the begin and the end keyword, whatever the statements are mentioned, all the statements will go for the execution. Okay. And in the example, like how this is all about the explanation, in the example, the first statement begins with the begin and end block. Okay, and it will execute at the 10 time units, and then the second starts with the 30 time units. That means what, 10 plus 10, 10 nanoseconds and 20 nanoseconds. When you observe totally how much, 30 nanoseconds of time after time. So it is 20 time after execution of the previous statement. So here in the example, after 20 times of data, so here after 20 times of nanoseconds of time delay, the statement 2 is getting executed. Okay, so here mentioned as 20. That means what, after 20 nanoseconds of time delay, the statements 2 is getting execution. So totally 30 nanoseconds of time delay. Within the 30 nanoseconds of time delay, both the statements 1 and 2 are complete the execution. Then coming to the parallel statements. So what does the parallel statements mean? The parallel statements are nothing but the statements are wrapped using fork and join keywords. Okay, and will be executed sequentially in the given order. So when it comes to these parallel statements, even though these the statements are parallelly executed, but still the statements are parallelly written, but still the execution, when it comes to the execution, the statements will execute sequentially in the given order. But here the mentioning of the statements, where the initialization of the statement will take place in between the two keywords, that is fork and as well as the join. Okay, in between these two, the parallel statements will be mentioned. And this parallel statement, it causes statements to be evaluated in parallel. That means the evaluation, when it comes to the evaluation, all the statements will be evaluated parallelly. Whereas in sequential statements, all the statements are evaluated. Okay, all the statements are evaluated sequentially, serially. That is, in sequential statements, all the statements are evaluated serially, whereas in parallel statements, all the statements are evaluated parallelly. That means what, at the same time, all the statements will be evaluated. But when it comes to the execution, in the sequential statements, they execute sequentially. Okay, and as well in the parallel, when it comes to the execution, all the statements are executed as well in the sequentially. Okay, the execution part goes for parallel statement as well as a sequential statement with the same manner, that is sequentially all the statements will execute. But when it comes to the evaluation, okay, evaluating the statements will be made as per the respective statement conditions. That means, for example, in the parallel statements, all the statements are evaluated parallelly. That means all the statements at a time. Whereas here in the sequential statements, the evaluation of all the statements will be done in serial, okay, serial fashion. Now, the block finishes after all the last statements complete. That means what here? The blocking of statement. Okay, the blocking of statements completes when all the statements completes their task. Okay, when the evaluation and as well as the execution of all the statements done, then the blocking, that means what? The statements with highest delay, it can be first statement in the block. So here in the blocking, when you are blocking the statements, always remember the statements with highest priority will come first and then it executes first. Okay, so the statements with the highest priority, the statements with the highest delay. Okay, the delay, if the statement for particular statement is having highest delay, then what happens? That particular statement will act as the first statement and it blocks first statements in the block list and it executes it first, and then comes the other statements. So here, this is an example. Example for the parallel statement. So module parallel statement, register A, initial and C, from fork to join. Okay, within these statements need to be executed parallelly. All the statements will execute evaluated parallelly and they execute sequentially. Okay, so for the parallel statements, we are using a keyword fork and join, isn't it? Whereas for sequential statements, we are using begin and end. Begin and end are the keywords. Okay, so within begin and end, all the statements will be evaluated serially and executed sequentially. Whereas here, executed sequentially but evaluated parallelly. So here, fork and the join, these two are the keywords where my statements, all my parallel statements will lie in between these two statements. So monitor A percentile, B percentile, time delay of both the inputs A and B, both the inputs A, time A, for example. So here, time A for 10 seconds of nanoseconds of time delay, 10 nanoseconds of time delay, my A value, the assignment I'm giving is A is equal to 0. Okay, so for 11 nanoseconds, that means 1 bit I'm increasing time from 10 to 14. Okay, so for 10, A is equals to 0. For 11, A is equals to 1. For 12, A is equals to 0. And for 13, A is equals to 1. And finally at 14, I'm just finishing all my block statements. So these are all nothing but the block statements, and each and every parallel statements, they are evaluated parallelly but execute the sequentially. Okay, and after all the execution completes, finally I'm closing all my statements with a finish. Okay, so finishing all my blocking statements, and finally I'm ending up with the keyword join. In the parallel statements, we'll end up all the sentences or all the statements with the keyword join, and finally I'm ending up all my program with the end module. Okay, why? Because I've started with the module and then I'm ending up with the end module. So this is what we will observe in the parallel statements. Okay, only thing we have to remember when it comes to the parallel and sequential statement is blocking statements are categorized into two types, parallel statements and the sequential statement. So in the sequential statements, all the statements are evaluated sequentially and the executed sequentially as well. Whereas here in the parallel statements, all the statements are evaluated parallelly at a time, but when it comes to the execution as well, all the sentences, all the statements are evaluated sequentially. Okay, here in the sequential statements, the keywords, within the keywords, all the statements will be initialized, that is begin and the end. Whereas in parallel statements, within fork and within the fork and join, we need to mention all the parallel statements. Okay, and when it comes to the execution, all the execution of the statements done sequentially, but evaluations can be made it parallelly. Okay, at a time, all the statements can be evaluated parallelly, and finally ending up with the end module. Okay, and now continuous procedural continuous assignment, as a topic is blocking assignment, blocking statement, procedural continuous assignment. Okay, so this is the topic. So we have done with the first half of the heading, that is blocking statements, and now come to the second half of the heading, that is procedural continuous assignment. So regarding this procedural continuous assignment, already in the previous classes we have discussed. Okay, when it comes to the procedural assignments, we will see the variables and the nets which are present in the procedural, and also when it comes to the continuous, both variables and nets will be present, but the executions will differ. Okay, whereas here in the procedural continuous, we will see it's a concatenation of both procedural and as well as the continuous. So here, what does this procedural continuous statement assignment states? The statements that allow expression to be continuously assigned to nets of variable and or of two types. So here, as I said you, in both the cases, procedural and as well as the continuous statements, we see the presence of nets and variables. Okay. And remember, when it comes to the nets and variables, all the variables could be in the scalar form or else in the vector form. Already we have discussed what is a scalar form and what is a vector units. So scalar units are nothing but the one bit of device, or else it stores only one bit of data. Whether, for example, I'm considering two circuits, circuit 1 and circuit 2. Okay, if you want to read the data, or write the data, it at a time reads the data and it writes the data. Okay, but sometimes when you transfer the data using RTL, register transfer language, sometimes what happens, I want to transfer the data. Okay, so my data is in some register. 3:0. So in some cases what happens, the data of 3, that is totally 4 bits of data. 4 bits of data if I want to transfer between circuit 1 and circuit 2. So sometimes at a time I can send, but in some cases I have to send with the one of parts. Okay, bit select or part select, that is what we call as. So in the bit select I have to send register 0th bit first, and register first bit, second bit, and third bit, and fourth bit. So this is how I have to send the data. So this nothing but the vector formation of sending the data, and here it is nothing but the scalar form. So when it comes to the variables or net, we see the variables or net, it could be in any kind, that is scalar or as well as the vector. So the statements that allows the expressions to be continuously assigned. So the expressions which are continuously assigned to nets or variables are nothing but the procedural continuous assignment statements. So here, when it comes to the procedural continuous assignment statements, there are two ways to follow. So first one is assign and deassign. The second one is force and release. So what is assign and deassign? This will overwrite all procedural assignments to a variable and is deactivated by using the same sign with deassign. So what happens here, we can write the syntax with the using assign and deassign. Assign and deassign means this will these two forms, what they does is they will override all procedural assignments to a variable. Sometimes what they will override, isn't it? So for example, I am taking my A is equals to B and B is equals to 20. So this is what I fixed, and sometimes I may override. That means what? Being a designer, I have a chance to alter. Okay, I have a possibility of altering the inputs that I'm giving. So here I'm just changing my 20 to 10 to 20 and my 20 to 30. So here what, this will override all the procedural assignment to a variable and is deactivated by using the signal with the deassign. If I want to assign some values onto a variable, I can assign directly a is equals to b and b is equals to 20. And now I want to do, when I'm assigning, it seems that it's activating, right? So now I want to deactivate. Being a designer, I have a possibility and I have a freedom that I can change. Okay, so now I want to deactivate. What I have to do, by using deassign keyword, I can override and I can change the values. So this is what happens in the procedural continuous assignment statements. So deactivate by using a signal called with the deassign keyword. And if you want to override anywhere, you can use a value, override some values onto your variable. You can use a word assign. And now the value of a variable will remain same until the variable gets a new value through the procedural continuous assignment. So here, basically what am I doing here? Basically, I'm giving my values onto a variable. A is equals to b and a is equals to 10 and b is equals to 20. Being a designer, as I said I have a freedom that I can alter the values, isn't it? So what am I doing? I'm altering my values. A is equals to 20 and b is equals to 30. And now, as per the sentence, what it says, if the value of a variable will remain until the variable gets a new value through a procedural assignment. So until a becomes 20, the previous one in first case, this is second case, for example, until a becomes 20, the variable, it will sustain with a value 10. That means what? Until my a becomes 20, my variable, for whatever the first variable I have given, it holds the same value. Okay, the value will not vanish, it will not disappear anywhere, and it cannot be overridden. Okay, so until and unless a value, another value assigned to a variable, till that extent, my given value with a particular variable will sustain. Okay, this is what we will see in this assign and deassign. So here, the LHS of an assignment statement can be a bit select or part select. So here in the assignments, assignment continuous assignment statements or procedural assignment statements or else procedural continuous assignment statement, whatever the statements that you are considering, after this is nothing but the assignment operator. Okay, assignment operator, and this is my RHS and this is my LHS, isn't it? So my RHS contains the expression and my LHS will contain the variables and nets. Okay, variables and nets. So here, as per this, the LHS of the assignment statement cannot be a bit select or part select or an array reference, but it can be variable or concatenation of variables. That is what I'm saying. So here in the assignment, equals to is the assignment operator. On to the left of the equal to, we have LHS. On to the right hand side, we have RHS. RHS is the right hand side with the expression we have. So on to the left hand side, we don't have the bit select or part select. We don't have any bit select or part select. Only the thing that we can have is variables and net. This you will have in only the LHS. Okay. So here you will see the register queue. It has, now I'm beginning, initial begin, assigning. What am I assigning to the queue? 0 I've assigned. Okay. After assigning 0, something or the other I wanted to assign again. Okay. So basically I'm assigning 0 initially. And after 10 nanoseconds of delay, I want to assign 1 for the queue. So what I'll do, first initially I'm assigning, this is what I need to mention, assign q is equals to 0. Then after 10 nanoseconds of delay, I wanted to give some other value. Okay. So when I want to give some other value, obviously I have to deassign again. Isn't it? First I'm assigning 0 and then after 10 nanoseconds of delay, I'm assigning 1. So here, before I'm assigning 1, I have to deassign it again. So that is what we are saying. My register q, I'm assigning q is equals to 0. So after 10 nanoseconds of delay, I wanted to assign some more value to Q. That is 1, for example. So what should I do? If I want to give some value, or else if I want to change some value to the Q, I need to do the deassign. So assign and deassign, and then end module. So this is about assigning and the deassigning. And when it comes to force and release is also one more kind of representing the procedural continuous statement. So here in this force and release, this is similar to like assign and deassign, and but also be applied to nets and variables. So as we see that assign and deassign, the statements, they can be applied to variables or nets in the same fashion. We see the force and release is also a kind of procedural continuous statements where this can be applied to the variables or nets. And the LHS can be a bit select of a net, a part select of a net, variable or a net, but cannot be referenced to any array and bit part select of a variable. So here what is it saying? Onto the RHS, my expression follows. Onto the LHS, my variables and net, I have my variables and net onto the left of onto the LHS, isn't it? So here, when it comes to force and release, I am saying that my LHS can be a part select of a net, a bit select of a net, and a variable or a net. Okay. When it comes to the assign and deassign, when it comes to assign and deassign, we have seen no parts. See, whatever he is telling in this force and release, he is saying that LHS can be part select and bit select, isn't it? Part select and bit select, but cannot be a reference of any array. It can be part select and bit select, but not a reference, isn't it? But when it comes to assign and deassign, I am saying that it cannot be part select or bit select. Okay, it cannot be part select or bit select. But here in force and release, it can be part select and bit select, but the reference of any array or part or bit select of a variable. So this is the important difference that you have to remember when it comes to assign and deassign, force and release. So the force statements will override all other assignments made to the variable units and is released using release keyword. So as I said, you deassign, assign and deassign. All the variables or else all the values onto your variables can be assigned. Similar fashion, all the values onto the variables can be override using force keyword. And then if you want to release, okay, or else when it comes to deassign, if you want to assign some other value after 10 nanoseconds of time delay, then you have to deassign, right? So here also the same fashion. If you want to release the value, or else if you want to alter any changes, if you want to change any, if the changes should be made anywhere here, so using a keyword release, we can release, okay, and then the changes can be made easily. So here in this particular example, we'll see register A and B, initial begin. So here forcing, using of keyword force, A is equals to 0 is equals to A and B, okay. 0 is initialized for A and B. And then after some times, okay, after some delay, I'm just releasing 0. Okay, for some or the other purpose, I'm just releasing 0. So use the keyword release and 0 and finally end module. Okay, this is what the difference between the force and the release. So here in this class, we have discussed two important points. Okay, two important statements. One is a blocking statements and other one is a procedural continuous assignment statements. When it comes to the blocking statements, we had discussed we have two types of blocking statements. One is sequential blocking and the second one is parallel blocking. So what is a sequential blocking? The evaluation will be made sequentially and also the execution of the variables, or else the statements can be made sequentially. When it comes to the parallel statements, we see the evaluation of the statements can be made serially. In the parallel statements, the evaluation can be made parallelly. Okay, all the statements at a time, the evaluation can be made. And when it comes to the execution of the statements can be made onto a given procedure. Okay, one after the other, the execution can be made. And coming to in the sequential statements, using begin and end, these are the two keywords that we have. We need to mention. That means what? Within the keyword begin and end, all the sequential statements will be should be dropped. Okay, within the keywords begin and the end. When it's come to the parallel statements, we will see fork and join. Using fork and join, in between the keywords fork and join, all the parallel statements can be mentioned. Okay, the execution will be made serially, sequentially in both the cases, in both the blocking statements, sequential statements or else in the procedural statement, parallel statements, we see the execution can be made parallelly. But the evaluation in the sequential statement, they evaluate sequentially, whereas it comes to the parallel statements, they evaluate parallelly. That means all the statements at a time, the evaluation will be done. Coming to the procedural continuous assignment, we have two kinds of the representation of the statements will be done in two forms. One is assign and deassign, and the second one is force and release. So when it comes to assign and deassign are mainly used for the alteration or else to change, in order to change. For example, when my q is equals to 0, so after this is what I'm assigning. So after 10 nanoseconds of time delay, I wanted to give some other number, okay, some other value I wanted to assign to my variable. So after 10 nanoseconds of delay, this 0 will becomes 1. So what should I do? I have to release that. So in order to release, I'm deassigning my q is equals to 0 just to assign the next variable which I am wanted to give, that is q is equals to 1. So only within assign and deassign, all the statements will be written. And when it comes to the force and release, so here also this force and release, if I want to give some value, see here force is equals to A and B, and then after some time or else after some time delay, I wanted to release so that I can give some other values onto the variables. And always remember, onto the left hand side of the expressions, the values can be given onto the variables. Okay, not only to the variables and also to the nets and variables. And here important thing to be remembered when it comes to force and release and assign and deassign, the only in assign and deassign, the bit part and bit selection and part selections cannot be considered. Okay, cannot be considered. Whereas here in force and release, bit select and part select can be considered, but here the reference of the initial values or else the reference of any array cannot be considered in force and release. Okay, whereas in assign and deassign, bit select and part select cannot be considered. And one more thing is variables or net onto these statements can be applied only onto the variables or nets. That means what? Only to the left hand side of the expression, left hand side of the assignment operator, these changes can be made. Okay, so this is about today's expression. I hope you have understood. That's it. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.